Okay, so a very big mark kind of topic, factorizing quadratics. A lot of you kind of sort of know what you're doing, but very few of you are really clear. I mean, like crystal clear on what you have to do on this. And that's why you're losing marks. You don't literally understand step by step what you're doing, and more importantly, why you're doing it. And that's literally what's stopping you from finding this incredibly easy, as I'll hopefully be able to show you in this video. So, first thing, hopefully you saw the last video, the introduction to factorizing quadratics. That really showed you, explained to you why we bother factorizing quadratics in the first place. I'm virtually 95% of you do not know that. So, watch that video. I'm not going to kind of repeat it again here. I think I'm probably repeating myself a little bit too much in some of these videos, but I guess it's better to stay on the safe side, make sure you get it and you're a little bit more bored. But hopefully I'll be going through this one quite quickly. So listen, the first things first. Obviously listen, quadratics come in all shapes and sizes, but you'll notice we'll be interested in the number in front of x squared. That's when we say a equals 1. Do you remember we said that all quadratics are in this form? Especially watch a quadratic equation video. The A I'm talking about is the exact same thing. So I'm saying let's start with where, just looking at factorizing quadratics, where the number in front of the x squared is just 1. Now, it is a little bit harder to do the ones where you actually have like maybe a 2 or 3 or whatever in front of the x squared. But once you see this video, there's only like a slight change. And I literally mean the slightest. Yes, it's harder, but it's not hard. So watch this video, understand this. If you get this, there's barely going to be any work left for you for the whole quadratic thing. So alright, so let's just kind of be clear. So this quadratic, hopefully you can see it's a equals 1 because the number in front of the x squared isn't a 0, it's a 1. If it was a 0, that x squared wasn't there. So really there's like a 1. This one is for like a equals 3. This one's a equals 14. You get it right. We're just bothered about the number in front of the x squared. That's 1. So this one, hopefully by the end of this video, you should be able to factorize, and that's a equals 5. So alright, let's get into this right away. Waste no time. And you'll notice on the side here, there's only 4 steps to doing this. Once you get these 4 steps kind of drilled into your head and you practice enough, super simple. So alright, the first step is set up your brackets. So you know that all quadratics multiply into double brackets. Now you'll know this, by the way, if you're not 100% why, think about when we expand brackets like this. Imagine if I told you to expand those brackets. These would expand to 2x squared plus 1x plus 2x plus 2. In these contexts. Okay? So basically, I've just given you the kind of answer, but obviously we've got to get you to the point where you could actually know that this multiplied out was that. So remember, multiplying out brackets and factorizing, just because this is factorizing quadratics, all that means is we're learning to factorize this stuff. But yeah, expanding brackets and factorizing are the opposite. So we're trying to find the double brackets, which if we multiply out, using those 4 things, we get back to this. So it's almost like we're reversing the multiplying out. So right, so the first step, set up your brackets. So now the first thing you should know with these is that the first term in this is going to be an x, and the second one is also going to be an x. The reason for this y is obviously if we multiply this stuff out, can you see we need to make an x squared? So obviously the only way to make an x squared is just x and x. It's not going to be 2x and x. That would be 2x squared. It's not going to be 2x. It's not going to be 2x and 2x. That'll be 4x squared. So that's the first thing to know. So that bit's already clear. Now after that, there's not much more we know about that. So here's what we're saying. we're going to just say, right, for the time being, we don't know the numbers, but we're just going to put in plus A and plus B. You see, so that's the whole of step 1. Set up your brackets with the plus A and plus B. And all the plus A and plus B are saying is, look, we don't know that yet. We're going to find those out. That's it. So there you go. That's step 1 done. So now I'm going to talk you through the actual, how we get. So here's the thing. Next step, we're going to find 2 equations. So this is how we go about it. And hopefully this should make sense. So hopefully you guys are happy that, look, we don't know what the 2 numbers here are, but we do know that once we do all this stuff and we pick the right A and B, we know that this is going to multiply out to x squared plus 3x plus 2. Hopefully that makes sense, because that's why we're factorizing. So it's trying to make these the same. It's a rewrite. So, alright, so that's great. So now what we do is just we're like, alright, well, we know these 2 are going to be equal, but they say, you know what, we're going to multiply these brackets out anyway. So look, the first term is x squared. The second one is plus bx. The next one is plus ax. And the final one is plus AB. Right, so now we know that this multiplied out is obviously, we're trying to make it equal, it has to equal that. Well, look, this is the real last step. So can you see already that these x squareds match up? So that's good, because what we're trying to do is we're trying to find the a's and b's, which if we multiply out are going to give us this. So we're trying to get this side equal to that side. So look, the x squareds are sorted, so you can forget about those. They're working absolutely fine. Here's the next thing. Can you see, and look back on the simplifying term video if you don't understand this, that this is an x term, because b is just a number which you're trying to find out. So if b is 7, we're going to get like 7x here. So this is still an x term. B might be even minus 6. That just say there's minus 6x's. So that's an x term. Similarly, this is an x term. And hopefully you guys can see, because A and B are numbers, a number times a number is going to literally give us a number term. So now look, on the other side, all of this has got to match that. So look, this is our x term, and this is our number term. So now here's the deal. We've got to make these x terms match this. So that's one equation already. So let's write that. And I recommend you write A first and B second. There's no technical reason why, but take me on this. Right? So we know that AX plus BX is going to have to equal 3x. And I'm dropping these pluses now. We know how all the pluses work. And secondly, so, that and that are going to match. Secondly, our AB is going to have to equal to, our number terms have to be equal. So we also know that A times B is going to equal 2. Let's just do that in the other color. Right, so well done. Final thing. But next thing you do with this one is you divide both sides by x, which just gets rid of those. You see? So now we have our 2 equations, and they are that A plus B equals 3 and A times B equals 2. And that's it. So now, you've pretty much done most of the hard work. So can you see, we set up our brackets down here, and we figured out those equations here. Now, do not be worried if that looked difficult to you. This never changes. This never ever changes. Also, even if there are some minuses here, you're still going to put in plus A and plus B here. So after you do this like 2-3 times, it never changes. And the reason you put plus A and plus B, because here's the deal. If we find out later that A equals minus 5, then imagine what will happen to this bracket. We'll have x plus minus 5, which will just turn it into x minus 5. So don't worry about that. It's always going to be pluses for both of them. less than anything. Alright, so next thing. Great. So now you've figured out your equations, and hopefully that makes sense to you guys as well. So alright, so next thing I say is you want to create a table for this equation. You'll always have, well, it's always going to be a times b times that last number, always. It doesn't matter if a equals 1, a equals 5, a equals whatever. This one is the one that really changes from a, like thing to thing. Obviously the number here will change, but I'll show you anyway. So, obviously, can you see, we can either, there's a few ways we can do this, but here's the way I recommend. We can either try to think of two numbers which add to make 3, and then hopefully stumble across the ones which also multiply to give us 2. But here's the reason I don't like that. There are literally a million ways which you can think of two numbers which add to give 3. So for example, say I made a equals 20, then I can make b equals 17. Say I made a equal 2, then b can equal 1. Say I made a equal 117, then I can make b equal minus 114. So you see, that there's, for you to consider all of those possibilities will take forever. So that's why you always go to this one. So here you go, this is what I recommend. Make a table for a and b. And now here's what you do. Let's think of all the possible ways which we can find, well, all the possible ways that we can have two numbers equal 2. And there's actually only 2. Now, first one is a could equal 1 and b could equal 2. Now, are there any others? Now, most people say, no, I think that's about it. No, don't forget this as well. Minus 1 times minus 2. Alright? So they're the two possibilities. So what we've done here is we ran through every possibility of this. Obviously, I've given you a really nice one where there aren't loads of possibilities. But as we go through the examples, you'll see that there's usually more. But yeah, so once you've done that, then you just go through all of the possible combinations, of which there is only 2, and find the a and b, which also add to give you 3. Hopefully you can see it's this. And by the way, just think about that. You know how in school, I think some of you have been told that, oh, when you're factorizing, you're looking for two numbers which multiply to give you that number, i.e., the two numbers, a times b gives you 2, these two multiply to give you that number. That's what I meant, yeah? So look, that's how this came about. And they're like, which add to give you that number. So that's how they got this. Hopefully that makes sense. But you'll see that that same thinking is wrong if the number in front of the x squared doesn't equal 1. But anyway, remember how we found this? So we've actually found our answer now. We've done that. We know that a equals 1 and b equals 2. So, hurrah! We've found. By the way, we've created the table. That's what I meant by creating the table for the a times b equation. Do you see what I mean? And finally, yeah, look, you just find the correct equation, which we did here. So, right, well done. So now it's done. We're literally finished. So all we do now is we literally replace a equals 1. So here's where a is. So we're going to replace it with 1. And finally, we're going to replace b with 2. Now, here's a very important point you should be thinking. Did it really matter what a equaled and what b equaled? As in, could we have also, what if we had stumbled across b equals 1, a equals 2? Now, the answer is, over in this example, it doesn't matter. Because if we plugged it in that way, we would have just got that. Do you see that? So that is exactly the same as that. It doesn't matter which order we kind of multiply the brackets. However, as you'll see when the questions get harder, when we kind of factorize quadratics where a doesn't equal 1, you'll be at this kind of stage. You'll sometimes find yourself in the stage of that and that. Now, it really matters which order we put it, because 2x plus 1 and x plus 2 and 2x plus 2 and x plus 1, totally different. Totally different. Guys, give me a second once I plug my charger in. Okay. So that's that. So obviously, listen, that's going to look quite difficult to some of you. I think some of you find that pretty easy to follow. But if not, don't worry. We're going to just go over it with another. And now all I'm going to do, yeah, for the rest of the video is run you through loads of examples, including when A and B and stuff can be negative and all of that. So yeah, that's literally it now. That's all we have to do. And here's what I recommend you do as well. Whilst I'm doing all of this stuff, when I give you an example, make sure you kind of pause the video and give it a little shot by yourself as well. So okay, let's go to the next one, which is x squared plus 8x plus 15. So I'll maybe go over this with a little bit more commentary. Then after that, I'm just going to start doing them, and hopefully you just after a bit can figure it out what happens. So okay, so we first thing, set up our brackets. So we know that, and we're going to put plus a and plus b. Always plus a and plus b, never changes. And remember the thinking here as well is that obviously, because we're trying to factorize this, we know that if we then multiply this out, we're looking for it to eventually end up giving us, you know, what we're trying to factorize in the first place. Okay? So now we've got some sort of, you know, we're trying to make this equal to that. I guess even like, I don't know if you guys know what this equivalent sign is. And that's saying like this is the same as. So I guess that's there. But don't worry too much about that if that doesn't make sense to you. So now what we're going to do is we're going to multiply out these brackets like that. And this is what we get. Get x squared plus bx, which I'm going to put in a sec, plus a plus bx plus a plus ab equivalent to or equals or whatever. Don't worry too much about that, by the way. I'm just being really mathematical about it. So remember, now we're trying to find the a's and b's which are going to make both sides equal. So firstly, the x squareds match. They should always match. We picked the x's so that they matched. Does that make sense? So right, so now listen, x term, number term. Over here, x term, and our number term. So what we do now is we're going to make our x terms equal and our number terms equal. So we've got ax plus bx is going to have to equal ax, from which we kind of cancel these x's from both sides, from every term. So we're left with ab equals 8, so that's our first one. And finally, ab, a times b equals 15. You follow me? Hopefully you follow me. So that was it basically. So that's how we get our two equations. And a times b equals, what am I told to? Sorry, I did that wrong. A plus b equals 8 and a times b equals 15. Yeah. So yeah, so now we've created our equations. So the next thing to do is create a table for the a times b equation. So we're going to think of all the numbers which can multiply to give us 15. And here's the deal, some of you at this stage may even be able to just kind of like, once you get to this stage, just know, I know the two values. You know, maybe some of you looking at it and you already know what A and B are. If you are, good. But otherwise, if you don't, it's not gonna, they're not going to get any extra marks. So just do it this way. So okay, A and B. Let's think of one way. So 1 and 15 is always a really obvious one. What's another way? Oh, by the way, always. So if you find one, we're both from positive and negative. You've always got the other one as well. So -1 minus 15. Don't forget that one. Another one is 3 times 5, and the other one would be minus 3 times minus 5. Now, look, I mean, realistically, this is where, like, I want you also to start bringing your common sense. Because again, 15 is okay, a relatively okay number. We'll see on the next example a real annoying one, 24. So you want to be a little bit smart, because we're looking, whilst we're writing A and B, we're only interested, as in we're only doing this table because we want to also find the A and B, which they add to give you positive A. So obviously, you know, two negatives aren't going to add to give you any positive numbers. Does that make sense? Like a negative add a negative is obviously just going to be a bigger negative. So really, look, 1 add 15 is 16, so it's not that one. And here you go. A equals 3, B equals 5. So our answer is x plus 3, x plus 5. And you can just always, here's the beauty of factorizing. You can double check you're right. Look, x squared plus 5x plus 3x plus 15. Okay, obviously that kind of combines to give you 8x. Alright, so that one's correct now. So let's rub away in again. So I'll give you one more kind of where everything's positive, you know, what I consider like easy-ish kind of factor. Alright, next one. X squared plus 11x plus 24. Now again, pause this, practice this. I want you to at least get to the point where you can make the two equations. If you can find your two equations, the rest is easy. Alright, so let's go. Set up our equations. A plus B. We know when we multiply that out, that's got to give us x squared plus 11x plus 24. Multiply that out, we're going to get x squared plus, I'm going to leave the blue now, hopefully you can follow me. Ax plus bx plus ab. Obviously it's still equivalent to this. So obviously they're already equal, so we don't need to worry about those. This is our x term, this is our x term, this is our x term. So that's how we made a first one. Obviously I'm skipping a lot here of explanation, but I've given it to you. Hopefully you can follow me here. And finally, number term, number term. Notice, by the way, that for all of these, yeah, it's all, and oh yeah, cross these off. So here's our two equations. Okay, notice how the two numbers, the A and B, always multiply to give you that number on the end. I think I mentioned that anyway, but that will always be true. I promise you that's going to be true. It doesn't matter what the number in front of this is, every single time. Now notice, whilst there's no number in front of the x squared, or in reality there's a 1 in front of the x squared, you're always getting that the two numbers also add to give you that, but watch out for that, alright? That isn't going to be true when this number changes. So alright, next step, we found the equation. That's the hard bit really. Alright, let's kind of think of all the possibilities. Again, some of you are probably looking at that and kind of thinking, I know it, and good. Because then you can skip this step. All we care about is finding this A and B anyway. But let's just show you how annoying, I've chosen this example to show you how annoying numbers can get. Some numbers can get. So all the possibilities for two numbers to multiply to give you 24. We've got 1 and 24, which means we've also got minus 1 and minus 24. What's another way? We've got 2 and 12. We've also got minus 2 minus 12. We've also got 3 times 8. We've also got minus 3 times minus 8. We've got 4 times 6, and we've also got minus 4 times minus 6. Minus 6. You see? We're looking for two numbers which add to give us a positive. Obviously these two negatives adding together won't give us a positive. So here we go. Which one of these adds to give you 11? That's 25. Not that one. That gives you 14. Not that one. Here we go. Yeah, our A equals 3, B equals 8. And that's it. We have now factorized this thing. See that? See how See how this keeps going, just like it doesn't change. Alright, so now I'm going to throw in some minuses in the original kind of equation to make things a little bit more trickier. Not much. So have a look at this one. X squared minus 5x plus 6. So again, set them up. And I think after you get pretty comfy with this, you won't even need to bother set them up. You know, after you do enough of these, you're just going to literally jump to this step. You're going to know that your two numbers are going to multiply to give you 6. And you know, at least when there's no number in front of the x squared, or as I keep saying, in reality there's a 1x squared. We also know that two numbers will add to give us, and be careful here, minus 5, not plus 5, minus 5. Yeah, minus 5. But, you know, for the sake of it, I'll show you how you get it again. Can I really be bothered? I mean, I'll do it one time, and then I'll start skipping straight to this, alright? But you should, and if you're still not feeling 100% sure how to do this, how to get to this, you should be writing this out the way I did in the last 3 examples. So this is the last time I give it for you. But if you're still unsure, watch the video again. Write it out again. But let's go. Yeah, so what we're trying to make this equal to minus 5x squared minus 5x plus 6. So we're trying to equal that to that. We multiply this stuff all out. You know how it goes. Yeah, x squared plus ax plus bx plus ab equaling to x squared minus 5x plus 6. That matches, that matches. They should always match. If they don't match, you mess these up. Yeah? And you're not going to mess it up when it's just x squared anyway. So the next thing, this is your x squared, so this is your x term, 2 x terms on that side, 1 on this side. So we need to make ax plus bx equals minus 5x. So we get that one. And then finally, we know that a times b is going to have to equal 6. And that's how we got that one. So that's the last time I'll be doing that for a equals 1. After that, I'm just going to be jumping straight to this. So make sure you're comfy on that. So okay, the next thing. Now we're creating a table for the a times b equation. So we're doing two numbers to give us 6. So 1 and 6, minus 1, minus 6. There's also 2 and 3, and minus 2 and minus 3. And again, that's all your possible ones. But here's another thing as well. Again, like, you can use your common sense a little bit. So you know that we're looking for two numbers which multiply to give us plus 6. So basically, these two numbers, if we're thinking of two numbers which multiply to give you a positive, these are either going to be positive and positive, or negative times negative. By the way, I'm just showing you a shortcut. You can always just write it out, and if you don't really want to think about this. But here's a little bit of a shortcut. So you're either going to have two positive numbers or two negatives. But in the second one, it tells you that they add to give you a negative. So obviously, a positive add a positive is never going to give you a negative. So really, you could actually get to the point where you didn't even bother considering the positives in this list. Never forget, the whole aim of this, yeah, the aim of these two steps here are to just find A and B. So if you can jump straight from here to here, that would be better, and you wouldn't need to do this, but just saying, yeah. So here we go, so carry on. So really, we could just look at these. So finally, we need two numbers which add to give us minus 5. Minus 1 add minus 6 would give you minus 7, it's not that one, it's these two. Minus 2 and minus 3 is minus 5. So A equals minus 2, B equals minus 3. So plug them in, and here's all that happens. I know some people get confused because they're like, oh, but this is a plus. Don't worry. Just make that into, so this is literally just plug it in. Yeah, and remember, plus and a minus, just a minus. So there you go. Your answer is x minus 2, x minus 3. Yeah? And you'll notice that whenever this is if you get like a minus amount of x's in your thing which you're trying to factorize, and then you've got a positive on the end, you always end up getting two negatives in the thing, always, because you need two numbers which multiply to give you a positive but add to give you a negative, and that's the only way, two negatives. So okay, so let's go on to another one. We'll do like two more of those, and then I'll go on to the kind of like probably the toughest ones. But again, none of these are tough, man. None of these are tough. I'm just showing you different kind of ways it can happen. So right, x squared minus 9x plus 18. Alright, so x. So set up your brackets first. And obviously we're trying to find the one which is going to give us x. We're trying to find the a's and b's which are going to give us an x squared minus that. Alright, and then you do your thing, and you should get to two numbers which multiply to give you 18, and also add to give you minus 9. So we're just focused on this. Now straight away, you guys should be thinking, look, you need two numbers which multiply to give you positive 18. So obviously, we can either have a negative number times negative, so either negative times negative, or we're going to have positive times positive. Yeah? No other way. If we have, one can't be positive and negative, because then it wouldn't multiply to give you a positive. That would be a negative. So when you look at the second one, you know that these two numbers are apparently also going to have to add to give you negative. Well, listen, a positive and positive isn't going to happen. So really, if you just want to skip ahead, you just should be thinking of you should be trying to find two positive numbers, sorry, two negative numbers, which multiply to give you plus 18. I know I'm getting, okay? But for the sake of it, I'll show you that even if you don't do that skip, then you can still think of it like this, alright? So let's kind of think of all the numbers which multiply to give you plus 18. 1 and 18, hopefully you shouldn't even be bothering with that, because you know it's not going to be that. There's also 2 and 9, minus 2, minus 9. There's 3 and 6, and minus 3, minus 6. There you go, that adds to give you 19, it's not that. That adds to give you minus 19, it's not that. This adds to give you 11, it's not that. It adds to give you minus 11, it's not that. This adds to give you 9, it's not that. This adds to give you minus 9, it's this one. So A equals minus 3, B equals minus 6. Plug those values back in. Yeah, if you want, double check, multiply that out, you'll get back to that. So that's factorized now. Let's go for another example. Rather give you too many than too little. Alright, one more. X squared minus 11x plus 10. So I'm just skipping straight to the equations. You do your thing, you should get that. You know, 8 times B give you positive 10. You know what? I recommend you maybe even writing positive 10 down. And they add to give you minus 11. Remember, minus 11. If this was a plus, then this will be a plus 11, but it's not, it's minus. There you go. Realistic at this stage, you know that you're looking for two numbers which multiply to give you, what did I say? Sorry, forget that. Oh yeah, by the way, hopefully here, you know, look, you can either have positive times positive to give you a positive, or a negative times negative to give you a positive. But we're looking for two numbers which add to give you a negative. So you could just skip and you should be thinking about negative numbers, but for the sake of it, don't know why. Alright, I'll do all the possibilities. So we could have 1 and 10, but we could also have minus 1, minus 10. I guess we could also have 2 and 5, and we could have minus 2, minus 5. Then apparently these have to add to give us 11. That adds to give us plus 11. Here you go. That one adds to give you minus 11. And don't bother checking these afterwards. Once you got the right combination, you got the right combination. There you go. So this factorizes to that. Alright. So, final one. final type. We'll run you through 3 examples anyway. Does that one even factorize? Yeah, it does. Okay, so here's a final type. So that's where you've got a positive amount of x's and a negative amount of the number at the end. So I'll run you through the actual full kind of how you figure out the equations for this, where it should not be causing any of you problems now. If it is, then listen, don't stress it. Then you ask me about it. Because here's the thing, I understand basically off the videos, either it makes sense or it doesn't. So don't beat yourself up or anything. So here we go. Alright, multiply that stuff out, always the same. X, X, X. Back with that. Remember, don't forget your minuses. Minus 10. There you go. We've got your 2 equations. So we've got a times b equals minus 10. And we know that a plus b equals 3. And just write that a little nicer. Green bit there. So right. So this one's not so clear, because it basically, you know, you need 2 numbers which multiply to give you a negative. So one of them is going to be positive, one of them is going to be negative. So they aren't really. So yeah, we're looking for a positive and a negative. What more to say on that? Not much. Just consider every possible thing. You know how before it was like, you know, you could work out which combinations to ignore. You can't on this one. The one thing we do know is, oh, actually no, there is a little thing. What we do know is we're going to have a positive and a negative, and they're going to add together to give us plus 3. So we're interested in the combinations of combination numbers which multiply to give you minus 10, where the positive is bigger than the negative. Otherwise, you're not going to get positive overall. But again, even if that kind of stuff confuses you, it's simple. Just create. Once you find these 2 equations, just look at the a times b one and just think of all the possible possibilities. So first one is a could be minus 1 and b could be 10. But here's the deal. Here's the other thing as well. You've got to consider that it could be 1 and this could be minus 10. Alright, so they're the 2 kind of possibilities for 1 and 10, if you will. And after that, you can do 2 minus 5. And you can also do minus 2 and 5. I think that's it, to be honest. Yeah, alright. So listen, these would add to give you plus 9. That's wrong. These would add to give you minus 9. That's wrong. These would add to give you minus 3. That's wrong. But these add to give you plus 3 exactly as we needed. So your A is minus 2 and your B is 5. That's it. Yeah? You can multiply them out, you'll find that you get that again. This is annoying. I need to kind of run to the bathroom. I want to get 2 more examples in. I don't want to pause the video. Let's get through this. Alright, x squared minus x minus 6. Now, only thing you have to be careful of here, the only thing that's going to trick you, is remember, there's a 1 here. Okay? There's a 1 here. So, try to now find the equations for this as best as you can. And what you should have got is that, as normal, a times b equals minus 6. Well, you should have got that a plus b equals minus 1. Don't fall into the trap and thinking there's a 0 in front of the x, because it isn't there. Trust me, if there was a 0 in front of there, it wouldn't be there. You would just see x squared minus 6. So there's a 1. And here we go. So now let's kind of do the AB table. Right, we're thinking of two numbers multiplied to give you minus 6. So 1 and minus 6, and also minus 1 and 6. We've got 2 and minus 3, and we've got minus 2 and plus 3. So this would add to give you minus 5, it's not that. This would add to give you plus 5, it's not that. This would add to give you minus 1. Good, it's this one. That's what we want. X equals 2, A equals 2, B equals minus 3. There you go. And finally one more, and we'll wrap up the video. And you'll see as well, as soon as we go, then I'm going to show you when, like, you know, the number front, the x squared is like a 2 or a 3 or something. It's so easy once you get this. So let's go for this. X squared plus 2x minus 24, one of the most annoying numbers you can have when you're factorizing. A times B is going to give you minus 24. Always be careful with the minuses and positives. And they're going to add to give you plus 2. So let's think about this. So let's go for A and B. And you know, the reason 24 is annoying, it's got there's so many ways you can multiply to get 24. So anyway, let's go for the possibilities. I mean, realistically, hopefully, I mean, what this is saying is, like, when these two add up, there's only, like, you know, there's a difference of like 2 plus 2. So in a way, you could almost like know this, like, this has got such a big gap between itself, like 1 and 24. You know, but we'll write it for the sake of it, because I'm just trying to show you how, you know, it doesn't matter, man. Like, don't worry about this stuff. Just write out. Just literally, I know I like to also kind of, you know, especially for those of you that feel more comfortable kind of with easier steps, I like to give you a little bit more. But here's this, but until you're fully comfortable, just run through this nice and slow and you will get the right answer. Yeah, can you see why minus 24 and 24 is annoying? Alright, so trying to find the ones that give you plus 2, that would be minus 23, plus 23, minus 10, plus 10, minus 5, plus 5, minus 2, all right at the bottom is our answer. A equals minus 4, B equals 6. Remember, it doesn't matter if you had got the A's and B's the other way around at all, because you get exactly the same thing. Remember, if we had done it the other way, you would have just got that, which is exactly the same as that anyway. So either one, doesn't matter how you write, it's exactly the same thing. So that's the answer to that. Alright, so we'll wrap that video up, and now let's kind of go and show you how to factorize quadratics for, you know, when the number in front of the x squared isn't a 1.